Michael, I'm going to present his. I'm going to film it.
So, right now we started the presentation of the magic box, and we talked yesterday about the different energies and why it's important to use these motors. The motor is only the heart beating, but heart without body is nothing. Body without heart is nothing too. You see in the motor only the heart without body. Body can be the battery, bulbs, whatever else. But this is the body. It's work for you, like a hand. Okay? I show you with the magic box application after the motor. I use the same motor, the small one, the dual pole motor. This is the same what you can vibrate. The same version, nothing else. Important is what we do with this energy. We can absorb this energy and save in the batteries. We can run light before we save in the batteries. We can run it without batteries too, only for the load. It's different things. And we have the chance to create in the transmission line more energy after the motor. And I show or change and manipulate this energy. Anyway, I think, are you here? Okay, right now. So, I started this motor. We can show what happens with the motor.
You can look on the screen too.
Okay.
It's easier to show it on this model. It's like a big model. We have the input from this one battery, and we have the output. This output I connected to the box. So, look at that. And after the box, I connected this to charging battery.
So we're doing the same thing that we were doing over there, the little black box, except I was only running one of the boards through the box out of the four wires. He's going the whole output going into that box.
So it's like a magnifier.
Yeah, sort of.
So, inside the transmission line, I put bulbs there, like Rick done before.
So what does it say on your box?
Huh?
What does it say on your box? What's the words on your box?
Oh, we can look at this later. I use 3-watt LEDs for showing this because a small motor, small device. And on this bulb, oh, I showed you before I have two connections. The wires be connected there. One end, I put the bulb there, and on the other end, I put the voltmeter. Because we want to show what's happening with the voltage between two ends at the moment.
Here, hold it up so I can see it. I can focus.
Oh.
Wait, don't move. Hold on.
You can see it on there,
Yeah.
on the camera.
Okay, move your fingers right there. The other fingers. Yeah, just hold on right there.
This is the both connection.
In parallel, so like
In
putting
parallel.
probes
Yes,
that go
red
right to
to
the,
red, black to black.
right to your connectors.
Yes.
You can even put his tongue on there. You'll see.
Okay. We want to know what's happening with the energy when we change something. So I connected this. Can you show the voltmeter? The voltmeter.
Which one?
Okay.
This one? Yeah, I'm looking at the voltmeter.
So I connected this.
It measures 12 volts across the battery.
Right now, this battery's slightly discharged,
Okay.
11.84.
Okay, this is a charging battery. This is the same
We-
multimeter.
We don't want it fully charged because we need to charge something.
So, for showing this, but we have the connection there. I put the bulb on the battery.
Yeah. Extended the leads, right?
Do you see the voltage? I don't really need that lighting there.
So this is straight off the battery again, right? So
Okay, do you see voltage?
Yeah.
Yes. Okay.
12.2.
Okay, the connection is okay.
Yeah, it's a good
Okay.
probe.
And the state-of-the-art multimeters. Harbor Freight Special.
Freight, yeah, but you get those free if you buy stuff. $3.99.
I got them for $2
Want to
each.
know, or we want to explain, this is the voltage what we have between battery clip, LED clips. And this multimeter show us the charging rate. So we have 11.94 volts at the time. Right now it's starting.
So he's got a trigger coil on that one to start it.
Five batteries in the last one.
This is 1 watt. I think you're running around 1 watt.
I need another multimeter.
It's different sensitivity to it.
It's got 50, see it's in my case. It's got 53 with a little red voltage for free. It keeps going to Harbor Freight. And here, I get a free this. Here, I need another free one. Here, I need another. Yeah. And then he takes them to Handfest and sells
You
them.
can give me a better multimeter?
Yeah. Anybody got any of those red? Oh, wait.
There's one right there.
Yeah, some of them are.
Oh.
These are old multimeters that cut 4 years ago. So. Oh, you got the same one? Oh yeah.
Need another one?
Here's another one.
I see.
Okay, this So, okay.
Yeah, this one works fine if you want to use all the same ones.
Okay, no problem. So the motor running. And here the special things. When we show on the multimeter, on this one, this is important.
Put your light on the multimeter so you can see the display.
No, you can. Yeah. You can see it in here.
Do you see this better?
Oh wait. Sorry. Shows better on this screen.
Can you turn the light on? Is something see there?
No, that makes it worse to see that.
Okay, it's important to look here.
Okay.
Okay, when you want, you come here and look at this.
Yeah, it shows on the screen behind you.
Yeah, it's on the
You
screen.
can see it.
Okay, I'm trying to get the. I'm gonna be focusing in and out, so don't
Okay,
get
this
dizzy.
is a zero. What's happening? You can show it on the AC side.
Oh wait.
You can show it. Come on, I do it
Okay.
here. Okay? And we can change it to the DC. Nothing happens. We have zero voltage here. Do you ever seen this before? What happens when we turn the LED off?
So, right now,
Nothing happens here. Inside, nothing.
it measures 0 volts whether there's a
Outside,
a bulb
nothing.
there or not.
We have no reaction. At the moment when we put the bulb in, we put the load to this system. We have no changing between the motor system and the bulb. We have no reaction. This is like a battery or motor system, like a completed transmission line. Nothing happens with this bulb.
So, just to clarify, at this stage of the demonstration, what is the bulb connected to? Is it directly to the output of the motor, or is it going through the box?
Box.
It's going through the box.
So 2 wires into the box, 2 wires out of the box?
Yes. And in this transmission, we changed the negative energy and connected this to transform it to 0-point energy.
But the output,
Different energies.
the output going into the other charging battery is still the same as
We
what's
charge
going in the
battery
motor.
here.
It's going higher.
We charge it at the same time. At the beginning, we have 11.994
94.
volts. Yeah, you can remember you.
Both are receiving the
At the
same.
moment, we have the charging voltage at 1222 volts.
And those are 12 amp hour batteries.
If you disconnect the LED, does the charging
Yes, it's
voltage
charging.
change?
Or does the charge rate change?
No,
Okay.
So the charging,
this is the. Can you show it?
Yeah, I'm looking at it.
Okay, and when we put the bulb in there,
so the charging battery is right now in parallel to that lamp
yes,
on the output side of the box.
yes,
So what's happening?
you have light for free.
Right.
This is happening, and you use it in this moment for running this. You need negative energy. It don't work with positive energy. We can't do this. It's run only with the motor system with negative energy. When we change the negative energy to 0-point energy, we can't measuring this. It's not possible to do this. This is because this other primitive multimeter can't showing us anything. We have 0. We can run more bulbs with this system.
How much energy is in 12 volts?
Huh?
There's 12 volts going in?
Yes, it's 12 volts input.
It's about 1 watt. I think. You're going to hook up the
Yeah, we see the apps.
you're going to hook up the power supply to that eventually, right?
Yes, after this, we're starting with the power supply.
Just to show
This is
you
important
the
for me
exact
to
amps.
show you. We run the motor now with this voltage. Can you show this?
Oh yeah, sorry.
Okay, remember this. 12 volts,
67.
67. Okay. We run the motor-
12.67.
Yes, it's charge and discharge. It go up and down, but it don't really discharge. You remember us of this number, and we show at the end of the presentation, how low go the battery down. Okay. So at the moment they used 2 LEDs with 3 watt. Right now we have 4 LEDs with 3 watts. Nothing changes.
So 0.
We have load, we have 0 voltage, and we have the same here. Nothing changes. Let us show. When you run it with mobiles.
How many bulbs we got?
This is what I told yesterday. This is unlimited system.
So are you connecting those bulbs in parallel? They're all in parallel now?
No.
Now there's
It's
series,
serial.
so it's now a string of 1, 2, 3, 4.
So I will put it so there, like you can look at this. We have 0, we have the same charging rate here, and we have the same on the input. It's don't change. So
Sounds like a self-runner to me.
Rick,
So you
can
want
you give me one LED?
a big one?
100 watt LED with connector? Oh, no, the other one is too bad. Oh, okay.
This is a cool thing. You want
So we start up with
The
100
grow
watt
light.
LED.
It's a grow light one.
Way more expensive than the white.
Those were $30, but you can spend a lot of money on those.
Oh, I know.
You have to find the right guys.
You can wait like 3 weeks, 4 weeks from China.
Yeah.
Slow boats.
But they somehow have this like almost free shipping.
Yeah, they do that e-pack thing or whatever, and it finally shows up like weeks later.
Can you get UVB LEDs now to help?
Oh yeah, yeah. We can do all those. See, they advertise those as grow lights, but they don't have the UV in them, so they're. Let me
Rick,
check.
your thing went
Oh,
out.
You know what? UVB is also good for human skin to produce vitamin D.
Oh, you mean the sun that nobody wants to sit in with all that crap they put on?
Well, you can't. There's not enough sun in the winter in the northern hemisphere. It's too low. Too much air.
Oh wait, somebody
I love
picked it up.
It actually prevents
well, it's gonna take a bit to start up though.
you don't overdo it. It's like it's a sweet spot where it prevents a mold.
Are the frequencies on this energy the same as the frequencies on the bulb when it's on conventional electricity?
The frequencies
You
of.
talk with me when you have
Oh,
questions.
we're not doing 60 cycles.
Did you have questions?
So the lights are in series, but the battery is in parallel with the lights.
Yes.
Yeah, so the battery's charging just like these other motors, except they don't have the capacitor pulsar. It's just the raw output.
And so it's correct to say that the voltage you're measuring across the charging battery is not necessarily the energy being applied to it. You're measuring the voltage level of the battery, right?
Wait, sorry, say that again.
The voltmeter across the charging battery is not measuring the energy being applied to it from the box. It's actually measuring the energy level of the battery.
Yes.
Yeah.
I mean, that was. I mean,
Measuring
there's a,
potential difference.
so the reason you're measuring voltage across the battery but not across the lamp is because the battery itself is driving that voltmeter.
Yeah, because you're saying that the lights are in parallel with the charging battery. How can we see?
Well, they're not
the voltage
exactly
the
in
battery?
parallel because there's something else happening inside the box.
You see the voltage in the battery here.
So what's happening inside the
But
box?
the voltage.
That's what the secret is.
Yeah, but what
Only he knows.
What the voltmeter is showing is what the battery is driving. I mean, the charging battery has been charged up to that level.
Yes.
We're not measuring that. The voltmeter is not measuring necessarily the output of the box. It's measuring how much voltage has been put into the battery.
Yes.
Right.
So how much load can you put on that? You know?
Well, look at this.
Can that box be modified so that you could regulate the brightness of the lights to bring them up to a normal room lighting level?
Yes. When we run the motor with 12 volts at the moment. The 100 watt LEDs work at the normal and in 36 volts. and it works. When we run the motor with 24 volts or 48 volts, you can run bigger LEDs or more LEDs. You can run motors with it or heaters.
What I'm getting at is the ability to regulate. For instance, if you have a heater, you want to regulate the output of heat. If you have lights, you want to regulate the level of lighting in your room. You see what I'm saying? Without necessarily changing the speed of your generator. You know, in my house I have a rheostat, and I can set the lighting of my room bright or dimmer, right? The heater can be on high or low, and so on.
Okay, this is a difference between normal physics and this physics. In the normal physics, we have cycle per second charging, and with this energy, you have voltage per second.
So,
This is the difference.
so Michael,
The faster you're running the motor, the more pulses you have. The charging rate is voltage per second, not cycle per second.
Your magic box, does it get hot, cold, or room temperature?
It's cooling up.
Okay.
It's cooling up.
okay, so people want to know, how can they tell that there's not a battery inside that box?
Well, because we don't see
Not really.
We're not measuring any voltage at the light level.
They want to know how can you tell that there's not a battery in the box? And I'm saying
Oh, this
the zero voltage output is showing you that there's something.
Okay, when you have the battery inside the box and you don't have zero voltage.
And also, you mentioned this is not using the pulsing capacitor.
I don't hear you.
Are you bypassing the capacitor on?
There's no capacitor on that. No.
Oh, it looks like there's a yellow capacitor on the back of it.
Oh, this capacitor.
Yeah.
No, that's for the
Running at
gener.
moment.
That's for the generator coils. It's
The
not even
generator
being
system,
used.
The 4 coils of this motor generator, it's don't working at the moment.
You're using only the 4 motor
I use
coils?
only four coils,
4 motor coils,
4 motor coils,
not the generator coils.
not the generator. When I start up the generator, right now I can run it. You see the discharging. Do you hear this?
Yeah.
This is a generator power, basic generator power. I don't use it for at the moment for presentation.
So will it still do the same thing or not with the generator coils? You get a different outcome what happens when you do run the generator coils? with
This is
the
positive
box?
energy output.
And then would you have voltage coming out of the meter connected to the lights then, or no?
No, it's not connected at the moment.
No, but when you connect it, she's asking, when you connect the
When it
generator,
connected,
you have positive energy,
What?
nothing else. it's just
250
right
volts
here.
AC.
So it'll come out right on
Yes.
that whole meter?
Yes. When we run it faster, when we run it with 4 or 5,000 RPMs, it's increased of 1,000 volts.
So if I put an O-scope on your magic box, would I read anything?
Yeah, we got one right here. You can connect that.
Oh, on the box. Okay.
On the O-scope.
We have a question before how much we can run it.
Okay.
How many LEDs we can run it.
Magic box.
Oh, one other thing too, I just noticed. So on these systems, when you have the neon bulb lighting up, right, that's showing you that there's not a sufficient load on there, right? So right now the neon bulbs are flickering. The more he puts on there, the brighter these bulbs get. And the neon bulbs on the other side of the circuit.
Can you measure the temperature of that box?
Wait, so you're saying he's adding LEDs and it's decreasing the load?
Yeah, and so these lights, in fact, he was doing that the other day and he blew out one of the transistors, so much vacuum coming through. So the room temperature,
because the load kept
73.
decreasing and decreasing and then he had no load practically.
I'm not sure.
So you add more lights, you got brighter? The more you add?
So the temperature is warmer over here because the LED is 86 degrees, 87. So these are producing heat. This is cold.
What is the temperature of the box?
And 74, just like No, 73, 74.
Can we come up closer and look for a second yet?
Yeah, let me finish the presentation, then you can come over,
Yeah.
and then,
When you want to come here and look at this.
yeah, just a few people at a time so we can still film
Look,
it.
look at this.
Like, go, stand over here more, and then, like, pass through, but don't keep
And
staying.
important to say, we have on this side of the motor, when you come here and look at this. We have 4 neon bulbs glowing here. 160 volts each. It's more power. We have many light output here. We have output on these bulbs. We charge the battery at the same time, and we have the same voltage on the beginning. How long we do the presentation, Ari? 20 minutes? 50 minutes?
Yeah, at least
Yeah, the
50.
battery have the same charging at the beginning.
This box is output is 0.8.
This is 0.1. This is new technology. This is the future. Can you put it? We can connect something.
So it's running at half an amp. He's gonna run it later with the power supply.
Yes, I show you now this power supply. You can see the voltage, you can see the error. I show you at the moment this with the batteries to show that we don't discharge the battery. We have the same voltage as we had before for 15 minutes.
Is that a battery charged with positive energy?
Yes.
This one is positive. These ones are all negatively charged.
Yes. This is the basic system. This is the same normal basic motor.
I bought these 2 batteries just a couple of weeks ago, and I've been charging and discharging them only with the negative energy. The same motor without the capacitor.
But what you're saying is the negative energy charge and the discharge is different from 0.8.
Yeah. This right here, this is 0 right here.
What's
All of these.
what I
So
want?
when you look up that, basically what I want to see, you don't see the spike that they show.
Oh, you see the spike.
Oh, you do?
The motor produces spikes. But what I want to
No, we're talking about this part right here.
okay, show me now. Show me. This is something special. This is
So what we're observing is that this battery has been running, but its charge level has not decreased. It's still at 12.67.
yes, this is
Now these are being charged. These batteries could not be taken directly from here to there.
with the materials, we can do this. We can change it to the other battery. Possible.
But if these are charged negatively, can they drive the motor?
Yes.
Still drive the motor.
Only when the battery completely will be charged with negative energy. When the battery is liquid, when the mass
Alfred said Midwest
Do you plan to actually eventually sell the black box there?
This is the research at the moment. After time, I think this is the future. Nobody in the world shows.
So, okay, I want to say something because there are some objections here to not revealing the information here. We said that we're going to show things. We're going to show you how, show you a lot of different things here, how to do the basics, how to get free energy. This, on the other hand, is way over. This is really high. It's never been shown before in public like this. So this is a show. This part is a show. It's our proprietary information under development.
Yes, a lot of people talk to the forums or whatever. Our unit, what is our unit? Nobody show our unit. I show the our unit. And this is really our unit. Because you see the same charging at the beginning. Dots and degrees. You have really power there. And you have low. You have to charge the battery.
Thank you very much.
Yes, because I create, in this system, I create special resonance. All particles in the universe resonate on this power. And when the when it resonates on the right way, you don't discharge. When you look at the electron has a spin. And it's spinning very, very fast with high speed all the time in the atom structure. But the atom don't lose his power. They don't lose energy. Why? They have the same mass, they have the same energy potential, and the same potential difference all the time. How we can do this? Without input power. Because each electron runs on free energy. Because each electron runs with 0 point energy. We can absorb it, we can manipulate it, we can transform it, we can create positive energy, we can create negative energy, or use directly the source. And the source is a 0 point energy. The negative energy or positive energy, it's only the reaction with other matter after the 0 point energy. 0 point energy is the beginning of all matter, beginning of the creation.
So it's possible that if this motor, the box maintains resonance with the motor and the charging battery, the running battery, that battery might drive the motor for a long time, indefinitely, as long as the bearings hold out and so on.
Yeah.
This battery run this system for weeks or for months.
Without switching batteries.
Without switching. This is important thing to understand. We can switch the batteries, but with the resonance system we don't need it.
Well, what would be the limiting factor? You said a couple of weeks to a month. I mean, like he said, wouldn't it run indefinite until you have a mechanical failure?
When I use the mechanical power, I can recharge this, yes. When I have a self-running
You
system.
said would that run indefinitely until you have a mechanical failure of the generator?
But he's got
I
the
don't
XL
use it
Plus
at
in
the
there, so.
When I use the generator coil, I can charge it up. I can charge both batteries at the same time. This is the balance system. It balance increased system at the same time. We have charging the primary battery and we can charge the secondary battery at the same time.
When you put a mechanical load on that motor, what happens to these levels?
Oh, to slow it down?
Yeah.
Oh, you lose the energy because it's in resonance at the moment.
Okay.
The RPM.
Destroy the resonance at the moment.
Is a specific RPM, the resonance?
Yeah, what's
Yes,
RPM?
yes, all. Yes, when we change the speed at the moment, it changes all system. When we put more batteries in the system, it's changing.
So that's the sweet spot.
Yes.
The sweet spot.
Yes.
Yeah.
Does the box have to adjust to maintain resonance as you vary the load? Like if you
Yes.
added more lights or less lights, more heaters, less heaters, it has to make adjustments to maintain resonance?
So
So it can do that within a certain range, probably for, hypothetically, you
Yes,
do that within a certain range for a certain input and a certain size of system.
Yeah.
Can you do inductive loads on that? Like heaters?
Inductive. Oh, not at the moment because we must directly on this connection. We don't can use because negative energy create no heat.
But if
This is no resistance at the
yeah, so
moment.
then if you put inductive, it should be Frosty the Snowman.
Yes.
The wire should be Frosty.
So you can change it. You can flip this, and then you can use it as a load.
So if I normally get hot,
Yeah, plenty of water.
With this transformer.
With the negative energy now, can you actually make the wire?
barely warm.
He brought it. So we need the glass of water. Right?
Oh yes. Can you give me the glass of water?
Where's the glass?
There. This comes the special things that I want to show you.
Oh, first I want to say, it says here something important. It does not matter what is in the box. It's
Yeah,
more important what's around the box.
Yeah, you can
Around
create
the box.
photos after this. I have special thinking what I want to show you after this.
More special than this?
Oh yes, yes.
This right here too.
I'm crazy.
This is going to do the same kind of thing.
Here's your water.
Oh, this is only water, yeah?
I already drank out of it. No, I just.
And it's not distilled water, right?
Not distilled water, it's normal water.
Yeah, so it's regular.
So it might have a few electrolytes in it.
Oh, sorry. Oh, I'm so sorry about it.
Don't try this at home in the tub.
Yeah, don't do this with positive energy.
So
The light
the primary battery is connected, but is this battery being charged? It's not connected.
This is not connected.
No, it's only for
But
holding this.
So this is back feeding through that circuit to charge that.
Yes.
Okay, just make sure.
This is a resonance system. This battery is in resonance with the motor. The motor is resonance with the black box. Box is in resonance with the battery, and at the same time it's react
Okay, just making sure.
to the beginning.
Not wireless. Okay.
Look at this.
still working?
Oh, because I'm crazy, huh?
So if that was
We have no power there.
if that was AC, that's an AC bulb.
This is AC bulb.
So if that was
I have water on my hands. Nothing happens here. Nothing. I have no discharging. Yeah. I can put the wire inside there. Nothing happens.
That's amazing. No change in the brightness.
This is Tesla.
So Mike, would you say the 0 point energy is coming through the resonance circuit?
Yeah.
Is that where you're capturing it?
It's like a pump. It sucks
It
it
is.
in.
Theoretically,
So it turns it off when you put it in there?
Yeah.
This is perfect resonance circuit. Yes.
Why does it go off when you put it in the water?
Go off. Go off.
The bulb.
it's not off.
Oh, the bulb is on.
It's on.
We can't see it.
So these LEDs often
do you
get
see that?
warm. But if these are running with positive energy, would they get warm?
No.
No?
It's absorbed negative energy.
No, if they were regularly run.
Oh, regular.
Yeah, they get warm. This is a heat sink.
Yes.
These are a heat sink on the back.
Yes,
These
because
got
it's
hot.
absorbed.
These got hot
It
on your
absorbs
system.
negative energy and
yeah.
react with positive energy. Again.
What if you were to run them off of this charged battery?
And they would get hot.
They
Well,
would get hot,
those
even though this is a negatively
no, but those are
charged.
30 volt bulbs.
Oh, you would need more voltage.
They would just barely flicker with the 12 volts.
So they're already lighting much brighter than they would at 12 volts.
Yeah, especially at only like around 1 watt.
You can create images, you can create, when you love it, share it on your social media.
Well, these are AC LEDs. This is DC.
These are DC?
Yeah, those are just straight LEDs. These ones are AC.
Pretty cool, Mike. And these didn't seem to get dimmer as you added more to the series channel.
No, and it keeps, you can hear the motor, or not to hear the motor, you can see the system just kind of adjust.
Adjust the resonance and then
Yeah.
it's up to brightness
So
again.
right now we can see, we want to show you what
The
happens,
scope, guys.
what happens in the bulb at the moment.
So there was a certain wave that I had on the website, and now you're going to see it.
Can you see it? You want me to hold that here for you?
No, I got it.
From the box here.
So I showed the wave and he was like, oh, maybe it's showing too much. wait for people to come and see it. See, look, it's the same time.
Oh, like DNA wave.
It's a helix.
Yeah. Yep.
Now you got to think of
This
this in 3D.
Yeah.
Don't
This
think of
is-
this as two-dimensional.
Okay.
So the two traces represent what's been picked up on each probe there, right? On each side of the light. So there are two traces. There's a blue trace and a yellow
Yes,
trace.
this is the two channels on each.
One channel from each probe, which is on each side of the light.
Yep,
Yes.
that's
So,
right.
If you hook the scope up to the output from the motor, then
And do this.
It's a 100 megahertz scope. Too.
Okay, so there's your traditional spike.
Yeah, this is traditional spike.
Okay, I'm just making sure.
You see basic spikes.
Yeah. Okay.
This is because I talk about transforming energy.
So it's the same thing that we have over there. It's just
Yes. This is only possible with to run this with motors.
And those are negative energy spikes.
This is not negative energy spikes.
Spikes going into your box.
Yes, this is the output, basic output of the motor. Any questions?
So, and over here we'll see the battery charging up, I guess, right? But this is showing the battery charge. Yeah.
Mike, have you done this on a bigger
That's going-
scale with the bigger motors yet?
Yes, I can do.
No, have you done it?
Yeah.
Oh, okay.
yeah. He's an old customer of mine.
Very old customer.
I know you already answered this question, but the speed of the motor has to stay constant?
At the moment it's constant.
Has to stay constant. That's how you get your resonance. That's how you derive your resonance. You get your pulses are kind of same.
Yes.
width.
What is the RPM? Okay. Can you give me a meter? In the box, the small box under.
You said the resonance box can adjust itself.
Oh, it's
So in other words, as the load changes and as the motor drive changes,
Here, you want to stand right
it
here?
will find a new resonance.
Let's use a thereafter capacitor. Because as you put a load on the reactor, it changes in capacity.
Right. Yeah. And for instance, when he changed the load of the lights, at first they flickered a bit, and then it had found a new resonance and stabilized.
Let's see it, Michael. Let's see it, Michael. Can you show it over here?
Okay,
Has to be $21.99. Can't be.
2100?
29,999,999 now.
It's important to this when we put the LEDs on the load. We have no changing the speed. Speed don't change at the moment. The frequency don't change at the moment. The complete resonance don't change this at this moment. It's only reaction between battery, motor, box, and the charging battery. It's not react with this battery. With this box, it doesn't change.
What different kinds of loads could you put here? So this is one type of load, AC LED bulbs.
We can run all loads what don't need current or much current, because the negative or don't work as a resistor at the moment, because negative energy can't produce resistance.
So an incandescent bulb would not light here at all? Incandescent bulb?
No.
Would not light.
Because it's run on resistance.
An electric motor couldn't run on this.
No. Because you have no electricity in the wire at the moment. You have only flux. You have the quantum vacuum flux in the moment.
It's your potential.
This is no potential difference. Because potential difference we can measure. We can't measure this. We have only the quantum vacuum flux at the moment. It is something like current, but it's mirroring.
So for the time being, the light emitting diode is the only type of load that
At the
practical
moment,
load.
practical load at the moment.
Maybe other devices could
The
be
most
developed.
cost of the companies or homes are light, because it's all the day, all the night working. It's not really heaters or whatever. It's light. All the day you have light. This is more important to do this for us.
Sorry, what about negatively charged batteries? Can these power incandescent bulbs?
Yes, yes.
So negatively charged batteries can power incandescent bulbs. They can power DC motors,
They can power anything
inverters.
Powers in it with an
except for
inverter,
this
you
kind
can
of
power
motor.
all
And
loads what you want.
except it can't power this motor to convert to more negative energy. Like can't run this motor and charge a battery with negative energy. No.
But it looks like you can put some kind of a converter box on this side and convert it back to positive energy if you want to have charge a battery that could go there.
Yeah.
If it's not a resonance system.
So Michael, why don't you show the sparks, or you want to do it?
Okay, I must.
Last time he did it, he blew out one of those bulbs.
Yes, less conventional. Blew up the balls with spark.
Like it was a,
That looks good. Let's do it.
Okay.
Hey, Michael, one more question.
so we're trying to get a picture of that.
You said that you did this with a bigger motor. With that same box?
Yes.
Yeah.
Yes.
These sparks are not the X-ray sparks or.
We can look at that.
I look good X-rays.
I discharge this now because we don't use it at the moment. It's still warm. Oh, this is a capacitor inside. This is because I must transform the energy. It's too much for this. I have capacitor inside. After time, it's go down. It's very big capacitor inside. So okay. Did you can give me this point?
This one?
No.
It's an old style rotor.
So.
That's great.
See if you can get it right while he's doing it.
So when you come near, you can see the spark.
Here, I'll let you get right now.
Whoa!
See the spark?
Yeah.
It's a spark without voltage. When we don't have voltage, what we have in the wire?
Michael, did you feel
Only
something?
current?
Feel some kind of shock?
What is current?
Yeah.
Can you turn it a little this way when you're doing it so I can get it? Hold on.
Did you feel something? Did it shock you?
Yes, it shocks.
Hold on, I can't.
Because
focus.
it's really matter discharging.
Here, try it again. Yeah, okay, now I got it.
So, the thing that shocked you is the spark itself, not touching the wires. You can touch the wire, even touch it to your
At
tongue.
this moment we don't absorb completely energy. This is because we don't touch the wire.
Put your tongue on that with the spark
I can
on?
touch it.
No, with the
I
spark
will
on.
discharge it. Because it's no voltage there, but it's discharge really matter at the moment. It creates matter and push it in the wire. You have positive discharging at the moment here.
So you're creating matter.
Yeah. You see the spark gap? This is matter discharging. Positive discharging. This is because it's blue and not red. It's gonna absorb this.
Where'd you get those little lights, AC ones that are here? You got them in
Conrad.
In Germany.
Yeah.
Yes, this is a very cheap. Made in China, I think.
Yeah.
Basically, what you can buy in
Are they glass?
Home Depot. 3 watts LED, AC. Nothing special. I use simple devices. I use cheap oscilloscope to show you. It's nothing special because normal scientists work with cheap equipment. When I show you this $1,000 oscilloscope, people think, oh yeah, to research of this I need something expensive.
Yeah.
It's just basic. This is cheapest multimeter,
great.
the cheap, the battery, nothing special. Nature is easy. Okay.
So we're all going to disappear when you turn on that thing?
Oh yes, we can show them this now.
The manager of this place was all worried that we were going to shut off the power.
All the time.
Well, I've been to one way back in '84 when that happened. Shut the whole building down.
Voltage is still the same.
Yes.
Yeah.
They have little bit less voltage because the motor is not completely in resonance at the moment. It loses something.
No, it's beautiful.
But it's okay.
Yeah, this was a 12 or a 1194 when we started.
Yes, and we charge the battery at the same time. I think it's great. So okay. Show must go on.
Very good.
Okay, so are we done with this motor? We're gonna do this now?
Yes.
So should we move all this out of the way?